A few questions on that temperature dependence. Let us see. The resistance of a heating element at room temperature. In bracket, you can remember that you take 27 degrees Celsius is 100 ohm. At what temperature its resistance will be 117 ohm if alpha is 1.7 into 10 raised to minus 4 per degree Celsius, 967 degrees Celsius, 1030, then 976 or 1027 degrees Celsius. Can you solve this? Temperature dependence wala? So I am only doing. At 27, it is 100 ohm. So 27 is for me starting temperature and 100 degree is starting resistance. You can assume this to be as R1. At what temperature resistance will be 117 ohms? So we know RT is R0 1 plus alpha delta T. Hello?
Yes, sir.
Yes.
This is temperature T1. Resistance R1. At what temperature resistance will become 117 ohm? So can I say R1 is R0 1 plus alpha T1, which is 27. Next is R2, which we have to calculate, is temperature alpha T2 we have to calculate. Please copy it in this.
Done, sir.
सर
Yeah.
सर R0 100 ओम नहीं ले सकते ना हम लोग, वो 0 डिग्री पे टेम्परेचर रेजिस्टेंस है ना?
हाँ वो 0 डिग्री क्या है? So RT R1 upon R2 100 upon 117 था 117 is 1 plus alpha into 27 upon 1 plus alpha into we have to calculate. So 100 equals 100 into 1 plus alpha into is 117 plus 27. So 100 plus 100 alpha into is equals to 117. 117 into 27 plus 117 into 27. So 100 alpha into is 117 upon 100 plus 117. This is nothing but 100 alpha into 117 minus 100 plus 117 27. So here 100 alpha into 70 plus 107 into 27. Therefore, into 17 upon plus 117 into 87 into 4. Right?
Yes, sir.
Just copy it. Just copy it. Guys. ठीक है?
Yes, sir.
रब कर दो पूरा.
Yes, sir.
The next exercise.
Yes, sir.
The resistance of a platinum wire is 5 ohm at ice point and 5.5 ohm at steam point. The resistance of platinum wire is 5 ohm at ice point and 5.5 at steam point. Find the temperature at which resistance of wire is 5.8 ohm. Option 120 degrees Celsius, 160 degrees Celsius, 200 degrees Celsius, and 240 degrees Celsius. What is meaning of ice point? 0 degree, na?
0 degree.
So when temperature is 0 degree, R0 is given 5 ohm. Then what? And 5.5 at steam point. So T2 is 100. Then R2, or you can say R at 100, कुछ भी notation लिख सकते हैं आपके ऊपर, समझने का है, is 5.5 ohm. So at some temperature RT, it becomes 5.8 ohm. That temperature T you have to calculate. I think data you all have followed.
Yes, sir.
Yes, sir.
So
Yes,
with
sir.
first two, I can get alpha, na? Okay, just write this much. Right.
Yes, sir.
Right.
Sir, done.
Done, sir.
So with first two condition, we can get resistance. We can get alpha. Substitute in any third equation, we'll get temperature, which is missing. So first one, I can say R1 is R0, 1 plus, or general formula alpha delta T. So R1 is 5.5, R0 is 5, change in temperature is 100. So this will become 5.5 upon 5 is 1 plus 100 alpha. 1.1 is 1 plus 100 alpha. So zero point 0.1 is 100 alpha. Therefore, alpha is 0.1 upon 100, which will be 10 raised to minus 3 per degree
10
Celsius.
raised to minus 3.
Now required RT, third one is 1 plus alpha delta T. R0 is 5, RT is 5.8, 1 plus alpha 10 raised to minus 3. This is temperature T, which is missing because starting is 0. So 5.8 upon 5 equals to 1 plus 10 raised to minus 3T. This is equals to 5.8 upon 5 minus 10 raised to minus 3T. 5.8 minus 5 upon 5, 10 raised to minus 3T. So 0.3 upon 5 into 10 raised to minus 3T. This goes up. So this will become 300 upon 5 is T. Therefore, T equals to 0.8. 800 upon 5 is T. T equal to 160 degrees Celsius. Clear ना?
Yes, sir.
थोड़ा फास्ट किया, इजी था इसलिए. So, mostly one sum is on temperature, one sum is on color code. हाँ सर, हाँ हाँ, जस्ट भेजा के सर. अच्छा देखता हूँ. हाँ हाँ देखता हूँ. आपको 1:30 तक बताता हूँ. ठीक.
Done, sir.
Done, no? One very beautiful sum you see. This is one conductor connected to another conductor. Length is L, area is A. This is having ρ1, alpha1, ρ2, alpha2 as specific resistance and conductivity and temperature coefficient. Question is like this: find the relation between ρ1, alpha1, ρ2, alpha2 such that the resistance of combination is independent of temperature. Resistance of combination is independent of temperature. That means resistance is neither increasing nor decreasing with increase in temperature. Copied question.
Yes, sir.
No, sir.
Resistance of combination is series or parallel?
Series, sir.
Yes, correct. Resistance of combination is nothing but series resistance. So that means they are telling series resistance is independent of temperature. What is formula for series resistance? RS?
R1 plus R2.
R1 plus R2. So as per them, this resistance at any temperature is independent. So when temperature changes, this R1 plus R2 will not change, na? As per them. That means total will
Yes,
not
sir.
change. So can I say that is R of first one at any temperature, R of second one at any temperature will be same as R1 plus R2. Then only resistance will not change.
Yes, sir.
Since they are telling resistance is not changing the total, resistance of combination is constant. So whether at any condition R1 R2 or at higher temperature they are same. So this I can say R1 into 1 plus alpha 1 delta T plus R2 1 plus alpha 2 delta T is R1 plus R2. This can be assumed as a 0 degree wala. Matlab R1 at 0 degree. So this is R1 plus R1 alpha 1 delta T plus R2 plus R2 alpha 2 delta T is R1 plus R2. Okay. Hello.
Yes, sir.
अब ये R1 alpha 1 R2 alpha 2 एक साथ लेता हूँ, इसको उधर लेके जाता हूँ. So we'll get like this now. R1 alpha 1 delta T plus R2 alpha 2 delta T equals to R1 plus R2 minus R1 minus R2. तो कैंसिल हो गया, मतलब 0 हो गया. करेक्ट. हेलो.
Yes, sir.
Yes, sir.
So it is like R1 alpha 1 delta T plus R2 alpha 2 delta T equal to 0. Throughout delta T you can cancel. अभी R का मतलब ρ1 L upon area alpha 1, ρ2 into L upon area alpha 2 is 0. L by A throughout cancel कर दो. अभी last time खत्म. So ρ1 alpha 1 plus ρ2 alpha 2 is sorry. This they can give you as option, which is correct relation.
Done, sir.
Done, sir.
What is current density? Current density.
I by
It is actually current per unit area. Current per unit. So current is I. Upon area is current density, but area is vector, therefore current density is in the vector form. So I is a scalar quantity. So can I say it will be dot product of J and I? Hello?
Yes, sir.
Is perfect. Done?
Yes, sir.
What is formula for equivalent resistance in series?
R1 plus R2.
In parallel,
1 by R1 plus 1 by R2.
can I say two resistance then product upon sum
Yes, sir.
and two equal resistance then
R
half?
by 2.
हाँ, मतलब हाफ ना ऐसा तीन इक्वल रेजिस्टेंस इन पैरेलल तो
R by 3. 1/3.
हाँ बराबर R by 3 perfect. Now this is one circuit I am telling. You have to tell me the formula for current. This is R1, R2, both are connected in parallel. Total current is flowing I. I want to find what is I1, I2 in terms of total current. Do you know the formula? मैं एक बार सॉल्व कर दूंगा.
वोल्टेज निकालना.
नहीं वो टाइम लगेगा ना, वोल्टेज नहीं निकालो हमने तो डायरेक्ट फार्मूला निकाल से कर दो. अब ये क्या फार्मूला आएगा आपको इधर डिराइव कर दो. वोल्टेज इज सेम, So I1 R1 will be same as I2 R1. That means I1 R1 upon R2 is I2. But total current is I1 plus I2. That means I is I1 plus I1 R1 upon R2. I1 if you take common, 1 plus R1 upon R2. That is I1 R2 plus R1 upon R2. So I1 will be R2 upon R1 plus R2 into I. So this is formula for current I. I2 will be R1 upon R1 plus R2 of total current. So if you look carefully, to get I1 we got R2 and to get I2 we got R1. Okay? Hello?
Yes, sir.
Yes, sir.
Yes. Now solve. Write the formula. And one sum I am giving with numerical value so that it becomes perfect.
Done, sir.
Done, sir.
Three ohm, 6 ohm, total current is 6. Find what is I1, what is I2. Four ampere I1.
Yes, sir. I2 is 2.
I2 के लिए directly subtract that way also. देखो दो तक resistance in parallel, you can use this formula and directly get the answer. अभी मैं 3 वाला और 4 वाला आपको बता रहा हूँ. In parallel how to get divided current. One resistance, two resistance, three resistance. This is R1, R2, R3, 1, 2, 3, current supply is 10. So suppose current I1, I2, I3 flows to R1, R2, R3. I want what is I1, what is I2, what is it? What is constant throughout? Voltage. Voltage. So it is like I1 is to I2 is to I3 is V upon R1, V upon R2, V upon R2. Correct?
Yes, sir.
And throughout that V you can divide. So it will be 1 upon R1, that is 1, is to 1 upon 2, because in ratio that VV will get cancelled. 1 upon 3. So 1 upon R1, 1 upon R2, 1 upon R3 ratio we have written. multiply throughout by 1 2 3 ka product, that is 6. So this will be 6 is to 3 is to 4. Now I1 is equals to, ये total कितना है? 6 plus
11.
11. तो 11 में से 6 part is I1 into total current. हो गया फर्स्ट वाला आंसर.
11.
I2 out of 11, I2 is 3 into total current 10. I3 total 11, out of that it is 2 into 10. So can you do by the shortcut method? I1, I2, I3. Again see, ratio of current is nothing but V by R, V by R, V by R. V is same, so throughout cancel. So 1 by 1, 1 by 2, 1 by 3. Okay? Hello?
Yes, sir.
Now 1 2 3 का प्रोडक्ट ले लो, एलसीएम लिया तो भी चलेगा. तो 6 3 2. Now 6 plus 3 plus 2 is 11. So out of 11, this total when you add it is 11. 6 part is I1. So from 10 it will be how much? Out of 11, 3 from 10 how much? Out of 11, 2 from 10 how much? This way you can get the answer very fast in 3 branches. Solve, then 1 or 2 more example I am giving.
Done, sir.
R1. This is 2M. So this is R1, this is R2, R3, R4, 2 ohm, 3 ohm, 6 ohm, 4 ohm, 10 volts supply. Question is find current and potential difference across each resistance. See, this is I, but it's total current. Huh? Hello? Hello?
Yes, sir.
Yes, sir.
Yes,
If I want total current, then first I should find total resistance. 2, 3, 6 are in parallel. 1 upon R parallel is 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4. That is 1 by 2 plus 1 by 3 plus 1 by 6. LCM is 6. 3 plus 2 plus 1. Okay? Hello?
yes,
So R will 1 upon R3 will become
yes, sir.
3 plus 2 plus 5 plus 1, 6. 6 upon 6, that is 1. So RP is 1 ohm. R total is 4 plus 1. That is R total is 5 ohm. So total current I is total voltage 10 upon total resistance 2 ampere. Now there are two ways to solve I2, I3, I4. इसका voltage निकालो, 10 minus that voltage ये सबका across में. Then V is I2 R2, V is I3 R3, V is I4 R4. Hello?
Yes.
I said I can find voltage across these three by subtracting. Find current. Current तो पहला total निकाला मैं by finding total resistance. These three are in parallel. I use parallel का formula. Then this and this are in series. So I use that series वाला formula. I got total current. Okay?
Yes, sir.
Okay. Please copy to this. We want current and voltage through each resistance.
Sir, 8 and 2.
8 and 2. अच्छा voltage जो है
Yes.
voltage across R1. Voltage across R1 is 2 into 4 8 पर. अभी देखो ये सबका across पे voltage कितना होगा? 2 होगा ना 2.
Yes, sir.
10 में से जो इधर चला गया बच गया इसके across में आएगा. Total is 10. Voltage across this we got 8. So this remaining voltage is 2 ना.
Yes.
क्लियर कर दो क्या ये पूरा स्क्रीन से पहले?
Yes, sir.
Voltage in second is same as voltage in third is same as voltage in fourth, which is total voltage minus 8, that is 2. So you know voltage, you know resistance, you can get I. So I can say I2 is V2 upon R2, which is nothing but 2 upon 2 1 ohm, and I3 is V3 upon R3, which is 2 upon 3, which we can write 0.67 ampere, and I4 is V4 upon R4, 2 upon 6, that is 1 by 3, 0.33 ampere. So we got this answer. Or suppose there was no need to find voltage, खाली current पूछा रहेगा. और okay, plus इतना लिखो फिर shortcut बता रहा हूँ फिर. If suppose we know total current directly and then how to find this I2, I3, I4.
Done, sir.
So I2 is to I3, the second method, is to I4, ratio method in parallel, will be 1 upon 2 because V is same, V cancel हो जाएगा. 1 upon 3 is to 1 by 4. 1 by 6. 1 by 6. So this will be 3 is to 1. When you multiply throughout by LCM, then 6, 6, 6, 3, 2, 1. Now what is total of this? 6 only I think. 3, 2, 1 cut total 6. So out of 6, 3 part. I3 out of 6, 2 part. I4 out of 6, 1 part. Into total current we got 6. Into total current we got 2. Total current we got 2. Total current we got 2. This method follow? If they give ratio तो direct कैसा कर सकते हैं? I2
Yes, sir.
is to I3 is V by R1. V by R2. V cancel कर दिया. फिर इसका एलसीएम लिया, उससे मल्टीप्लाई किया। तो 3 2 1 का 6, आउट ऑफ 6 3, सो टोटल इज इनटू 2। 6 में से 2, तो टोटल में कितना? 6 में से 1, टोटल करंट कितना? This is nothing but 1. This is 2 by 3. 1 by 3. Same answer है। So remember both. Any one can be useful. Ratio of current पूछा रहा था, तो ये मेथड अपना ज्यादा अच्छा था। फिर से बताऊं? हेलो, फिर से बताऊं क्या?
नहीं सर।
No, sir.
Understood. Done?
Yes sir.
Yes, sir.
Three ohm, 12 ohm, 4 ohm. This is 6 ohm, 12 ohm. Question is again find current and potential difference across each resistance. I'm giving you 2 minutes. You all try. Then I'm solving this. अरे कनेक्ट बताए तो ये टोटल करंट इधर से सपोज I, this will be I1, I2 becomes I, then again here I3, I4 again becomes I. So we have to find I1, I2, I3, I4, I and voltages. Resistance you can give the name R1, R2, R3, R4, R5. Take 2 minutes. Let me check whether you are able to find at least total current. Any of you got total current?
Is it 1?
So one.
One is correct.
1
Yes.
ampere.
Correct. One is correct. See, ये दोनों का पैरेलल कितना मिला? Parallel of first part 12 6 प्रोडक्ट का कौन सा हम यूज किया? 12
Yes.
into 6 upon 15. 72 upon 18.
72 by 18, 4.
Same way, parallel of second part is 12 fours are 48 plus 16, that is 3. Now total resistance is 4 plus 3 plus 3, which will be 10 ohm. So total current is 10 ohm. Total current we are getting now. Total current 1. Yes, anybody got further answer?
Yes, sir. Yes, sir.
What is voltage across 3 ohm?
3 volt.
3 volts, that is correct. Then what is voltage across 12 and 6?
Sir, 3.
12 and 6 also 3 you are getting?
Yes, sir.
No, that is
Yes.
4 volt है, wrong है. See, ये सर्किट है अपना 3 ohm. इसमें से टोटल करंट आ ही गया, we calculated as 1 ampere. So 1 into 3, 3 volt इसके अंदर चला. अब ये दोनों का इफेक्टिव रेजिस्टेंस 4
Sir,
था
4
ना?
and 5 is 3 volt. उल्टा कर.
This effective was 4 of this circuit. Current flowing is 1, so effective voltage will be 4 here. And this current total effective was 3. Effective answer. Current will be same to effective total current flows. So 1 into 3 is 3 volt. Hello? Hello?
Yes, sir.
Yes.
So with this I got idea. I1 is voltage 4 upon first resistance 12. I2 voltage 4 upon 6. So 1 by 3 and 2 by 3. Any doubt in this one? ये वोल्टेज दोनों का अक्रॉस में कैसा निकाला मैंने? टोटल करंट मालूम है, टोटल रेजिस्टेंस मालूम है, तो टोटल वोल्टेज दोनों का अक्रॉस में मिला 4. सेम वे I3 will be equals to voltage is 3, resistance in first part is 1. Then I is V by R. Resistance is 12. No? Hello? 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 Hello?
Yes, sir.
Current in 12 ohm is voltage in 12 ohm V upon 12. Current in 4 ohm is 4 by 12. So this is 1 by 4, 1 by 3. Followed all the current distribution?
Yes.
Yes, sir.
4 3s are 12, 4 2s are 12, total is 4. So we got current V by R, V by R, V3 by R. V by R. V is 3, R is 12. V is 3, R is 12. V is 3, R is 4. 3 by 4. Should I explain or you followed?
Followed, sir.
Followed.
अब एक एकदम सिंपल सर्किट का इक्विवेलेंट रेजिस्टेंस देखते हैं. कॉम्प्लिकेटेड का देन हाउ टू सॉल्व इट बाय सीरीज पैरेलल और एक कॉम्बिनेशन आएगा मिरर मेथड दूसरा आएगा इक्विपोटेंशियल मेथड आल्सो समटाइम्स कॉल्ड फोल्डिंग मेथड और बाद में बता. फाइंड इक्विवेलेंट resistance between A and B. Find equivalent resistance between A and 2 ohm, 4 ohm, 3 ohm, 2 ohm. This is A, B, find equivalent between A and B. Just again take 2 minutes. Try to make this entire circuit like this. That means एक ही resistance between A and B. That is equivalent. Now चलो मैं आपके लिए help करता हूँ. 2 and 4 are in series or in parallel?
Series.
2 and 4 का series कितना?
6.
6. मतलब ये 3 और वो 2 and 4 का series इधर हो गया 6. So this is 3, इसका 6, 3 और ये 4. And this is 2. This is 2. Between A and B, I want 6 and 3 are in series or in parallel?
Parallel.
Parallel.
What is 6 and 3 ka parallel?
2. 2.
2. To get answer 2, you did 6 into 3, 19 upon 9, which is 2. तो ये दोनों का एक रिजल्ट हो गया 2. Now 2, 4, 2, 2. This 2 and 4, they are in what?
Series.
Series. 2 and 4 ka series is what?
6.
6. Now 6 and 3. 6 and 3 ka parallel?
2.
2 and 2 ka series?
4.
So final answer is 4. Okay. Now this is only dangerous sum because इसको कैसा click होता है, it's very difficult to judge. I have taken like this. जिधर भी equivalent चाहिए सोचता हूँ current उधर से आया तो क्या होगा? अगर same current flow हो गया तो series सोचता हूँ दिमाग. Divide हो गया तो parallel. Closed end से start करना हमेशा. Open end से नहीं, closed end से. ये close आके direct answer हो गया. Complete diagram. Now in electrostatic, you have completed till how much? How many sums?
20.
अरे 20 क्या? अभी 100 तक
27 तक किया।
नहीं 100 तक कंप्लीट करके रखो अभी 100 तक।
Okay.
ये कल आपका लेक्चर है संडे को एक्स्ट्रा लेक्चर। व्हाट टाइम आई कैन कीप?
Before 6 is possible.
Before what?
6 o'clock.
Anytime possible. We'll just discuss if it is possible for everybody. Or earlier slot can I keep?
Yes, sir.
8 to 9.
So we have
Sir,
bio.
can we keep
8 to 9.
after 11:30?
I can keep any time. Aryan, you tell your convenient time.
So because 10:30 to 11:30 test है.
Arey Baba, tell the convenient time, dear. What is
Sir,
there?
can you keep in the evening
Evening what time? 10 to 11.
after 6?
Yes, sir. Evening would be better.
Evening will be better.
Yes, sir.
Oh, evening. Can we plan 6 o'clock?
Yes, sir.
I'm not there after 6.
After 6 or before 6?
After 6, I'm not there. Before 6, anytime is fine.
So 5 to 6.
Yeah.
Or other student 5 to 6.
Yes.
No,
Yes,
sir.
sir.
Actually, I have to go for that college filling form. That's why.
Tomorrow is Sunday.
Yes, sir. आकाश में जाना है actually इसलिए.
संडे शाम को बोला लिया उसने।
हाँ, मतलब 3 to 6 के बीच में जाना है.
आप 3 बजे पहुंचो ना उधर।
और उसके पहले आकाश का टेस्ट है इसलिए.
3 to 6 में जाओगे तो क्या 3 घंटा लगेगा? 3 बजे जाके 5 बजे आ सकते।
सर तो आप 6 बजे रख दो ना.
अभी एक स्टूडेंट आपके सामने ही बोल रहे हैं कि नहीं फ्री है। मैं तो बोल रहा हूँ मुझे कोई भी टाइम चलेगा। मैं तो बेस्ट बोलता सुबह कर लो और फ्री हो जाओ। आर्यन सिंह कितना बजे आपका है क्लास? बोलो टेस्ट कितना बजे?
Sir, 10:30 to 11:30.
10:30 to 11:30 ना। तो आपको 8 to 9 में क्या प्रॉब्लम है?
Sir, we have bio.
है.
Then Sunday we'll cancel. So much constraint, how can I help you? That day also I told you find one time and tell me. 5 o'clock आपका क्या प्रॉब्लम है? आप बोल रहे हैं इजीली पॉसिबल है 5 o'clock. 5:30 to 6:30 मैनेजर?
Yes, sir.
यस श्लेषा, ये हाफ एन आवर एडजस्ट करोगे क्या फिर?
हाँ, okay, sir.
हाँ फिर अनिकेत आपका भी हो जाएगा हाफ एन आवर एडजस्ट?
ओके सर.
देखो आप आगे पीछे हो जाएंगे चलेगा, ट्राई करना 5:30. आई थिंक यू कैन मैनेज. चलो एक संडे तो ट्राई करते, फिर ये हो गया तो हमेशा यही फिक्स कर दो.
ओके सर.
देखो नहीं तो मुझे बेस्ट लगता था फ्राइडे, एक बार मैंने रखा था लेक्चर 5:30 to 7, ये बेस्ट था फ्राइडे वाला. तो संडे का टेंशन ही नहीं रहेगा. याद है 5:30 to 7? आर्यन सिंह आपका 5 बजे खत्म होता है तो 5:30 आपने बोला चलेगा मुझे.
Yes, sir.
ये कर दो क्या फ्राइडे फिर हमेशा फिक्स 5:30 to 7? तो फिर संडे का ना वो टेंशन नहीं रहेगा ना आपको. देखो अभी तो कल मैं ले रहा हूँ 5:30 to 6. ठीक है?
Okay, sir.
कन्वीनियंट ना फॉर एवरीबॉडी?
Yes.
Yes, sir.
ओके.
Yes, sir.
एंड बट बिफोर दैट 1 to 100 आप कैसे सॉल्व कर पाओगे? बिल्कुल नहीं, फिर कल तक हो जाएगा आपका. कर पाएंगे क्या? इफ यू हैव नॉट डन.
नो सर.
एक बार किया है वापस तो इम्पोर्टेंट कर लेंगे.
हाँ देखो होने के लिए क्या है, आप 2 घंटा रात को ज्यादा जागो हो जाएगा. अपना लिमिट को एक्सटेंड करो. 1 to 25 तो किया ही है, till 100 you have to try again. डेडलाइन रखो 100, नहीं हुआ तो कोई हार्ड एंड फास्ट रूल नहीं है, बट सी टू इट दैट यू आर स्ट्रेचिंग योर बाउंड्री. So tomorrow 5:30 to 6:30 we are meeting. Done?
Yes, sir.
Fine.
Okay.
That's all.
Thank you, sir.
Thank you.
Bye, sir.
Bye.
थैंक यू.
Thank you. Thanks a lot.